So let's cd into the molecules directory of Nell's home directory, which contains some protein data bank files containing a few molecules that are apparently relevant for the research. Say we were somewhat interested in how big these files are, we can use the command wc for word count to actually count the length of these files. If we want to know all of them, then we can use a wildcard like this to actually word count the contents of all these files. This star will match anything, so we will match all files that are something.pdb. And if we do this, yeah, we get a list like this. So some numbers, and then all the names of the files, and then the total. Let's look at the man page for word count and see what it does. So it gives you word, line, character, and byte counts. For instance, we can use /L to see how many lines there are in all these files, or /C to see how many characters, if that's the only thing that we're interested in. So suppose we were interested in somehow scripting our way to figuring out which file in our directory actually contains the largest amount of lines. So we've already seen that we can do word count /L. This gives us the lines. Then we would like to sort this thing and we want to store it. We could, of course, grab the text somewhat and then copy paste it to somewhere, put it into a spreadsheet and work with it. But obviously that's not the kind of thing we are after. We're after using the shell to script this and be able to continue doing our analysis. So one extremely powerful thing that the shell can do is that it can redirect the input and output of commands. So this syntax means that whatever is printed out of running wc/l star.pdb is not displayed on the screen, but actually stored in a file called length.txt. So now I used cat to inspect the contents of that file. We can actually store the contents inside a file. Now the shell also comes with a command called sort that will enable us to sort the length of the files. So if we do sort /n length.txt, then it actually sorts this according to the numbers out there, which enables us to figure out which one is the shortest and which one is the longest. Well, let's try without it. That's the next thing. It's doing almost the same thing, but it's suddenly different. So the thing is that normally sort puts things into alphabetical order, whereas the /n tells that you actually want to sort according to numerical values. So you probably know that if you've got a bunch of files in a directory, one of them that's called something like 1 to 10, then 1 is sorted next to 10. So you've got 1, 10, 2, 3, 4, 5, 6, 7, 8, 9, because they're sorted alphabetically. So then you end up putting a 0 in front of all the small numbers to make sure that they're sorted alphabetically in the same way. And the /n exactly means that you don't have to put that 0 in there because you're sorting according to numbers and not according to the alphabetical orders of the numbers. So we can confirm that by, again, inspecting the man page. A lot of options. Yeah, and this one says compare according to string numerical value. So that's not overly helpful, but it means that we're converting it to a number before sorting rather than sorting according to the string. And again, this one has also, interestingly enough, has a /r command for reverse, which is similar to what we discussed before for the other commands. So we could continue our attempt of actually sorting this thing by sorting the input. So we're sorting whatever comes in length.txt, and then we're storing that into a new file called sorted length. And indeed, that looks like what we had before on the output. Now, if we want to we're just interested in the smallest of these files, the one we're interested in figuring out which file of these is the smallest one. We can use the command. We can use a command to pick out the first line of a file, which is called head. So if we do head/1 -1 sorted length, then it will print the very first line. If we do that -2, then it will print the first 2 lines and so on. Similar, there's a command called tail, which will show the last line, and so on. Now we've created all of this by creating all these temporary files and then running commands on the temporary files, but there's actually a better way of doing this, avoiding the creation of all these temporary files that we're not really interested in. So if we use the vertical pipe character, so just a vertical line here rather than the redirection into a file, that will actually produce that output and then use that as input for the next command. So we've actually avoided creating the sorted length text file here. And we can take that one step further and using another pipe character to pipe the output of word count into sort and then pipe the output of sort into head. So that's actually telling it word count can count the number of words, the number of characters, and this one is telling it that we're only interested in the number of lines. So if we did /c, then we got the number of characters. It's still the same file, but it's now 422 characters. Let's have a play around with trying to get something like this working. You could experiment with replacing head with tail, figure out what's the last line. Now that doesn't give you the biggest molecule, so we will have to do something else to actually remove that line and then find the next last line. So a combination of head and tail should do that. So we could try experimenting with that and trying to get something like this working locally and see that you can pipe commands like this together. This is a simple example, but it should show why the shell is very powerful, because you can, with very few characters, chain together commands and build programs that use simple basic steps to do powerful stuff in combination. So the idea is now we're figuring out how to write and what we want to do. And then when we end today, then we'll have this in a script. So you just execute the script and then you do all the analysis. There's a few illustrative figures in the lecture notes that may be of interest. Yeah, so this illustrates what we've been talking about. For reference, how it goes to the shell, or it goes to a file, or it goes into another command. Now we've done this on some simple files, so let's try to extend this to the actual data set that we're interested in analyzing. So we're going into the North Pacific directory here. And the data directory, which we've seen before, contains a bunch of data files and those two programs. So let's try inspecting them. So we're going to do basically the same analysis just to find the length of the text files. No, so we moved into this directory. So North Pacific 2012-73. So we're trying to do the same thing and looking at the contents of these files and see what's going on. And again, we're using word count to find the number of lines, sorting it, looking at the 5 first ones, and we can use tail to look at the last 5 ones. Interestingly enough, there's one file that looks a bit out of place. All of them are 300 byte of 300 lines, except this one, which is only 240 lines. So that's a bit odd. So if we actually look at that file was 2018B, so we can look at that file, and then there's probably something wrong with that file, so we might want to exclude that file from our further analysis because it looks like the apparatus wasn't correctly configured or doing something else because it didn't take the same number of measurements as in all the other ones. Other interesting thing is that all the files are supposed to end with A and B. Then there's one here that ends with a Z. So let's look at if there are more of those. And indeed there are 2 of those files. So those also fall out of place, are also out of place compared to the rest of them. So we probably also want to exclude those from the further analysis because they're different kind of measurements according to the expected protocol. And there's a way that we can actually use ls to make sure to find all the files that have the right name. So they should end in either A or B. So if we use a syntax like this, then it means anything and then a character which is either A or B .txt. So the thing inside the brackets are matching either one of them. And that prints then the number of files. Now, if we want to count how many of these files there actually are, we can again We could again use a pipe, so we could actually just pipe that to word count /L. So now I've used the list option to ls to get this printed as a list, and then I'm just piping the contents to word count /L. So that counts how many lines there are in this list. If I remove this .ab, then we get 17. So we're excluding 2 files by only looking at the ones that end in ab.txt. The combination of these two simple things, listing and word count, enables us to build something that can count the number of files with a certain characteristic using quite a few, not very many characters, just because we can actually pipe the output from one command into another.